In this video, I'm going to give a demonstration of how to obtain data from the MEO EOCHA data portal. This data will be in the form of raster imagery, and I will show how that data can be exported from the portal and brought into a standard GIS package. I will also demonstrate how you can download temporal data of different variables and bring that data into a spreadsheet package for further analysis. To begin using the MEO portal, simply visit the website shown in the red text on the screen now. Okay, so to begin with, I need to load up the data portal in my web browser, so I'm just going to start Chrome, and I already have in my bookmarks the URL I mentioned earlier. Now by default you'll notice that training mode is enabled. I'm going to switch that off by pressing the button here on the top toolbar, but if it's the first time that you've used this system, you might want to have the training enabled to give you a little bit of additional information. Now because I'm a guest, because I've just arrived at this website, I do have access to some data and some functionality, but if I want to have more control over the work that I do, and I would like to have access to more data, I need to log in. So to do that, I select the option here on the top right to log in. I've already created an account, but if you haven't already, you can just register for an account and then use those login credentials in the future. So now that I've logged in, I will have access to a little bit more functionality and data than I would otherwise have had at the beginning. Now the first thing I want to do is just zoom into the area I'm going to be interested in today, which is in southwest Kenya. And I need to select some data because at the moment the system doesn't know what I want to do, what data I want to select. So to do that, I need to select the first icon on the toolbar, which is helpfully named Select Products. And when I click on that, there's a whole list of different types of information and data that I can download. It's classified here by precipitation, soil moisture, temperature, vegetation, and so on. If you're not entirely sure what some data is actually about, the little blue information icon, if you press that on the right hand side, it will tell you which sensor, the product, a description, the start and end date, and the spatial resolution, and so on. Now I'm really just going to download a few little bits of data. I've got the air temperature, and I'm going to have a look at land surface temperature and maybe some rainfall. So I'll have a look at some of the data generated by TAMSAT at University of Reading. So we've got some decadal and we've got some monthly rainfall data there. And once you're happy selecting the different data products that you want, underneath the select column, you can just click on save. At this point, of course, the system doesn't know what geographical region do I actually want that data for. So I have to tell it which bit of the map that's available on the screen I would like to download data for. And it's very easy to do that. At the top toolbar there's this pencil icon which is draw or select area of interest. And when I click on that, I'm able to draw a box, a rectangle, which represents the area that I want the data for. And when I let go, you'll see that there is a red rectangle, and that red rectangle now represents the area that I would like to download data for. So I've selected the data products that I'd like. I've told the system which geographical area I'd like to download that data for. So to begin the process, I just click on the Get Subsets button on the top, and it'll begin to download data that's available at the moment from EOCHA. So at the moment I'm just going to show you how to download one image, and for the purpose of this demonstration, the first one here, which is from IRI in Columbia, University of Columbia, New York, and I've got inferred maximum air temperature. That's something that might be useful looking at what the maximum air temperature would be related to mosquito dynamics for diseases like malaria, for example. There are 3 buttons along the bottom here. The red X is just to remove it from my list. The one on the far left would simply add that to the map here on the screen, and if I click on that, you can see that it's now added that to the map on the screen. But to actually download it, it's very simple, just the little icon in the middle which says download GeoTIFF, and GeoTIFF format is very widely used by many people who work with climate and disease models, and it will open in most GIS packages. So all I need to do is click on that, and you'll see now that that data has started to download to my browser. And when it's finished, I should have a pop-up box here that tells me that the data is available. I'm just going to minimize the web browser. I've already created a folder on the desktop here, and I'm just going to drag the GeoTIFF data into that folder. And now I'm able to bring that into my GIS package. Now at the moment I have in the background my ArcMap, and I've already got on ArcMap vector layer, which is the country boundaries for Africa, and the district boundaries for Kenya are shown there as well. So I can just add that data that I downloaded from EOCHA a moment ago, and that's now appeared. That, remember, is the red box that I drew on the screen. It's the same area. And if you're familiar with ArcGIS, you'll know that you can actually change the color scheme to something a little easier to understand, a bit more intuitive. So now we can see here that by changing the colors, the lower temperatures are shown in the blues and the higher temperatures are shown in the red. And of course I can repeat this for my other data products, for precipitation, for the land cover classification, and all of the different data that you saw in that list originally. So once I've done that, of course, I can create my model, my malaria risk model, my chikungunya risk model, which most people who are going to be using this system would already have up and running. And this is just a very, very quick and efficient means of getting that data in the format that can be used immediately by the software that people use. And as you can see, brought in a very good quality data product that's already georegistered, ready to go. Okay, so now that we've seen how to download raster data to put into our GIS package, I want to cover how we would download longitudinal data over a period of time, the sort of data that you might need to put into a spreadsheet or a graphing package. And there are 2 ways you can do that. You can just click on the map and have it generate a chart for you, for which you can download the raw data, or you can specify a very specific point. I'll show you first of all what happens when you just click on the map. Obviously you first have to, as we did before, select the types of data that you're interested in. If you wanted to, you could also change the date range here as well. So you could select a different year, a different month, a different day for it to actually generate your graph for you. I've left it at the default, which will be the previous 365 days. So in order to produce my graph, all I do is just click on at any point. So I'm just going to arbitrarily click here in the southwest of Kenya, and you'll see that when I do that, the district that is it's surrounded by that point, in this case it's the Rift Valley district, will also be shown. And there's a little place marker icon for the point at which I did actually click. Now it takes a few moments to draw all of the data down from the EOCHA server. It's searching now its database for the data that I've requested and for that particular point, and then it's generating the graph and displaying it, so it takes a little time. But you can see already on the left hand side here that we've got a nice graph which is showing the inferred maximum air temperature for that point that I clicked on. And there are a number of different buttons along the top here. The first one is to plot a line in the chart without and with. The default is with. You can switch on and off the legend. You can remove the chart as you could remove the raster data in the earlier example. You can set average line parameters, regression line parameters, change the zoom, and of course if you want to just download the data, you click on the little download chart data icon here on the left, and you can download data in CSV format, and the default here you can see is XML format. And it's you can see the XML structure here. You've got the date and the time. You've got the value here, which is air temperature in Celsius, and that's the standard XML sort of file structure. I can save that very easily just by going to Save As, and I'll leave that at the default name, which is saving into my EOCHA folder. Once you've actually got that data, of course, you can open it in Microsoft Excel. Now, in Excel, of course, a CSV file, which you could download, will open immediately, but with XML being quite useful for people who run mathematical models, they may only want to use XML. There is a function here, if you switch on the Developer tab with Excel, there is actually a function here to import data. So we can import data, and then we just go to where I saved it on the desktop in the EOCHA, and there is the data that I opened before, and I just click on import, and so that's the data that it's imported. And you can see here that this column represents the actual temperature values, and like any other data within Excel, you can just insert a graph, and you can change the size of it, and you can change the x-axis so that it represents the date and time, for example. And change the other values that you're used to, if you're used to creating graphs with Excel or any other package. You can see how that data that was previously only visible as a graphic here is now available to do further analysis with in your spreadsheets. And you could have a number of different types of data there that you might want to do some statistical analysis with. So back here we can see that while I've been playing around with Excel, that other data has opened. So we've got a whole range. We've got some temperature, precipitation data, and all of this we can select and bring into our spreadsheet. Or indeed, we can use both the XML and the CSV data in a mathematical model that we might have written with computer code separately. And the second way in which we can download data, rather than just arbitrarily clicking on a point, is to select a particular pixel. So on the top here you can see under Select Pixel, you're able to give the latitude, longitude coordinates. I'm actually going to give the coordinates for Bomet in Southwest Africa, which is minus 0.7838 degrees latitude and has a longitude of 35.3407 degrees. And I click on Set Coord, and that sets that particular coordinate. So rather than just arbitrarily clicking, I've been able to select a very particular coordinate, in this case for the town of Bomet in Southwest Africa, and then I just click on the Get Charts icon, and just as before, this will now retrieve the data from the MEO portal and produce a range of different data values. It will tell me if any of the data is not available, either because of the date range that I've given, or perhaps because of the point that data doesn't cover. But by and large, you can see that the data will appear fairly easily. In this example, Bomet is a town where tea cultivation takes place, and there are 111,000 people and only one hospital with 300 beds. So this is an area that I've been particularly interested in looking at, because the workforce is mostly agricultural in that area. And if you wanted to have a look at things like exposure to mosquito vectors for diseases like chikungunya virus or malaria or any other disease, then seeing what the temperature and the rainfall patterns and the precipitation, the vegetation cover in that area represents over a period of time would enable you to get a good idea of the disease dynamics. And of course, a combination of both the raster data in a GIS and the temporal data going back any time period you wish to specify, together those data would be necessary and are very important for generating estimates of different disease risks. And finally, the last thing I'd like to show you is just a couple of the icons, the different functions along the top here that I didn't cover earlier. One of these is the Layers button under the Map Controls section. And you can see that the map by default is what we call terrain light. You can also change that to a colorized terrain. You can have open street map, which is very useful if you want the names of towns and cities and villages on there. The blue marble, which is quite pretty, particularly when you begin to zoom out. You can actually see some of the physical properties using blue marble. And there are other different settings that you can change here to alter the visual appeal of the base map. The other thing that I did touch on before was the settings, and you can see the settings icon on the top here. If you have an account, if you've registered for an account, you can change some of the default settings which are retained between each session, so you don't have to keep setting them each time. You can switch on and off. You can toggle things like automatically selecting an area of region around the first pixel that you select, what that area should be. In this case, I've selected 500 meters around a point, and it will take the readings within that catchment area. You could make that a kilometer or several degrees. It's entirely up to you. And also the default time periods when generating the graphs. By default, it's 365 days. If you wanted to go back further in time, you could change that. And indeed, if you were only interested in the last couple of months, then you could reduce that number as well. And once you've saved that, that will be retained for you each time you log in between different sessions. So overall, this is a system that has put together through an awful lot of hard work a great deal of different data products, and these data products are biologically meaningful to the different types of disease, vector-borne disease, that different medical investigators would be interested in. And these data have come from a wide variety of different sources. And in previous years, those of us who work in this field would have spent probably a third of our time simply going through the process of getting the data, which means going to a variety of different websites, downloading the data that we need, and then possibly having to change the file format into something that our software can work with. This system makes that much, much easier. No longer is it necessary to have to trawl through a variety of websites. Instead, you just go to this one location, this single portal, select the data that you want for the period of time that you want, and the data can be downloaded straight to your computer quickly without any problem. And of course, because it's in one location, you can be sure that the data is reliable and consistent because it's been through a series of checks, and it's been put together in a very thoughtful way. So I totally endorse this system, and I think that once people in the medical community, those who do research as well into the effects of climate and climate change on disease, are aware of this system, that it will become a one-stop shop for those people who need that data for their existing models and to develop new models in the future.